Okay, do this and then we'll go to the next chapter. By then we should have everybody here, hopefully.
So when I go on YouTube for videos, it's difficult to filter through legit and BS.
Yep.
Could you possibly, would you mind, giving me a suggestion or like the videos to watch or people to subscribe to or whatever to watch the video?
Yeah, I could probably do that.
Because those really help me personally.
Yeah.
Understand the systems and their function.
Okay. I know some of these questions ask about scope patterns, I don't expect you to remember that, because we didn't do it, or know it, I should say. Anybody not done? I guess that's a no, right? Okay,
1, 2, 3.
what's wrong?
1, 2, 3.
What?
1, 2, 3.
I don't know what that means.
There's one in the first and two in the second.
Oh, there's one person in the first row, 2 in the second, 3 in the third.
Oh, I got you.
All right, we ready?
Okay, let's do our 1, 2, 3.
What is the best way to test the output of the Hall effect sensor? C. Using that scope.
Who else got C?
I did at first, and then I went with D.
Okay, it is C. Hall effect sensor, the best way to check it is to use a scope to observe the waveform, because remember, the Hall effect sensor is going to produce a digital signal. Okay.
What is spot condition?
Okay?
What was it? B.
Mm-hmm.
What was that?
C.
What is it? Purpose of
Split damage from coil, yeah. Normally you don't have to do that unless you have a system that has just one coil for all cylinders.
What is the purpose of testing magnetic sensors? B.
Which one?
B.
C?
B as a boy.
Okay. So what are we doing? What is a magnetic sensor? Crank sensor, cam sensor, right? Would that deal with fuel delivery?
No, see.
Ensure the magnetic strength of the sensor is okay. It's C for that one, okay?
What is the first step in the diagnostic, in the diagnostic process, or everything in the work condition? See?
Same thing it always is, right?
Visual inspection.
After you verify that you have a problem. Perform thorough visual inspection of the ignition system. Okay. So much for your 1, 2, 3.
What is the purpose of switching the suspected ignition coil to another position? Is it B or A?
Okay. Yes, A. So what they're talking about here, do you understand what the question's asking?
Yes, because you're testing, that particular coil to see if it's bad or not.
Right.
The only way you can, well, one of the ways you can do that is by switching it to another, position.
Right. So let's say you got a 4-cylinder engine and you got a P0200, right? Cylinder number 2 misfire, right? And you suspect the coil might be bad. Plus, it's an easy thing to check because most engines that have the coil and plug system, it only takes a minute to swap the coil, right? So what you would do is you take the coil out of here, switch it with number 1 or whatever, right? And if the misfire moves to this cylinder, you know that coil is bad. It's an easy test. Now you know that coil is bad, so you know, put a new coil in it, it's gonna fix it, right? If the misfire does not change position, if it's still misfiring on number 2, it's not the coil. Because you just swapped it with another one, right?
Right.
Okay, so that is the correct answer, but I just wanted to make sure you understood the purpose of what they were asking.
What should be done before replacing the ignition control module? C.
Intruder module is probably ground receiving ignition power, yeah.
Number 8, what is the purpose of placing spark plugs in order for inspection? A.
So what they're saying here is, let's say you take the spark plugs out of your car, you have, say, a 4-cylinder engine, put them in order. This came out of number 1, this came out of number 2, this came out of number 3. That way you know which cell that spark plug came out of, because sometimes you can identify problems with the engine just by looking at the spark plug. So if you got oil on number 2 spark plug, you go, okay, that problem, number 2, oil control, that cylinder, maybe a piston ring, maybe a valve seal, something like that. So at least you know what cylinder that spark plug came out of. So if you take them all out and you just mix them up, you don't know which one came out of where,
Yes.
right? Good idea to put them in order when you take them out, so you know which cylinder may have an internal problem or whatever. All right, the next few I don't expect you to know because we didn't cover scope patterns. What did you get for 9 anyway? A? Okay, good. 10 is D, short spark line ignition system pattern. 11 would be 1.5 milliseconds. Upward sloping spark line. Mechanical problem, linear fuel mixture. Okay, 13, what's cause oil foul in the spark plug?
I guess D.
No, it's
E-
B.
Either one of these would work.
Oh,
Either one of those would give you oil and spark plug. Yeah, so if you got C or D, you're good.
What was 12?
B.
B.
Well, yeah, B. Indicates mechanical problem. All right. Purpose of using a scope,
A.
individual cylinder patterns, for spark lines, oil out, all that stuff. Well, all right. Okay, so you missed our ignition video, but not a big deal. Okay. Okay, so our next chapter is 73. The rest of the chapters we have to do for this week are pretty quick. We'll get to them all today.
We're gonna be taking tests off a specific amount of chapters each week, like last chapter.
We
or-
may do the test today, just depends, but we'll get through all of it.
Okay.
we do, we can get a head start on next week, because as we know, we're missing 2 days out of this.
Yeah.
So, all right. Should be on 867. This shouldn't be anything new to you. These computer fundamentals we've talked about before. You should kind of know what's going on here already. Parts of computer function, sensors, inputs, outputs we'll go through. Modern automotive control systems consist of a network of electronic sensors, actuators, computer modules designed to regulate powertrain, sport vehicle systems. Automotive computers use voltage to send and receive information. That is how they talk, right, through voltage signals. So basic functions for a computer are just like any other computer. Whether it's your computer in front of you, your phone, car, whatever. They all work the same way, right? They receive information from the sensors, process it, have a storage capability, and then decide what to do with the information that it receives from the sensors. Okay? Nothing new here, right? Input. Receive voltage signals from the device, maybe a switch or a sensor. Processing is a term used to describe how the voltage signal is received and handled through a series of electronic logic circuits. Storage is a place where program instructions for a computer are stored. They include the ROM, the EEPROM, the RAM, and the CAM. You should be familiar with those anyway. After the computer is processed, the input signal sends voltage signals or commands to the devices in the system, such as actuators. If you think about it, a computer works the same way we work, right? You take in information, you process it, you decide what to do about it, right? Make sense?
Yes.
Pretty simple. Computers were designed to kind of work the way we do. They can communicate and control other inputs or outputs and input functions. They communicate with each other through communication lines. All the control modules on the car talk to each other. We've talked about the potentiometer before. This is typically a 0.5 volt variable resistor. Produces an analog signal. Good example of that is your throttle position sensor. We've talked about this as well. Some sensors and things on cars produce an AC or analog signal. Has to be converted to digital in order for the computer to process it, understand it. Use an AD converter inside the computer to do that. Purpose of your information or your data lines is to share information between controllers. Parts of it, CPU, memory, programs. Nothing new there. Clock rates and timing. Computer's crystal oscillator generates a steady stream of 1-bit long voltage pulses. Both microprocessor and memory monitor the clock pulses while they're communicating. They communicate at different speeds, which you're familiar with. Baud rates we've talked about. You've seen this before, right? You know what's inside of it. Everybody's seen inside electronic devices by now, hopefully. Capacitors, resistors, chips. Typical engine map developed from testing and using vehicle computer to provide optimum ignition timing for all speeds and engine load conditions. They call that engine mapping. Clock generator, that's your crystal there. Produces a series of pulses that the microprocessor and other components stay in step with each other at a steady rate. PCM typically under the hood now. Input sensors, here's a good list of some of the inputs that the engine's gonna use. RPM sensor, how fast is the engine turning? Switches or buttons. Manifold absolute pressure, that is your manifold pressure, the vacuum inside the intake manifold. Mass airflow sensor, how much air is coming into the engine and what is the temperature on it? Engine coolant temperature, oxygen sensor, throttle position, vehicle speed. We're gonna go into each one of these sensors in detail as we go through this, okay? So you know how each one of them works, what they do, the importance of them, that kind of stuff. Computer will send voltage signals or commands to operate actuators. And for network communication, typical output devices are your fuel injectors, lower motor control, transmission shifting, idle speed control, evaporative emissions. We've talked about drivers before, high side driver, low side driver, right? That's just a transistor inside the computer that will either provide a ground path or a voltage source to a device. PWM, pulse width modulation, what is that?
A method of controlling an output using a digital signal.
Okay?
Doesn't that control like the speed? The
It controls, so, control, I'm not sure what you're saying, control the speed?
Like, the speed at which it sends the signal?
Okay, let me give you an example of what pulse width modulation is. We've talked about duty cycle before, right? That's the amount of on time that something is on. And it's in percentage. Let's say if it's a 50% duty cycle, it's on half the time, off half the time. This is how it does it. That way the computer doesn't have to just turn something on and then turn it off. It can pulse width modulate it, meaning giving it a duty cycle. So it can be on as much as it wants or off as much as it wants without it just being continuously on or off. This is a good indication. You'll see this in milliseconds. If you look at a scan tool for injector pulse, it will give you the injector pulse in milliseconds, and that's pulse width modulation.
Oh, I see it here on page 871, the method of controlling it, is that what it says?
Yeah. Okay, this is a very simple fuel pump relay circuit. You should be familiar with the relays by now. Remember I told you the relays are all pretty common as far as the terminals and what they do. You should know what 85 and 86 are, and 30 and 87. Those are the 4 common relay terminals. So looking at this picture, what's going on here?
The PCM is adding voltage to the relay that goes to the fuel pump motor.
Okay. What does it take to make the relay operate?
12 volts.
It takes a power and a ground on terminal 85 or 86. It doesn't matter which way it is.
Okay.
This can be positive or negative, this can be positive or negative. Doesn't make any difference. The relay's still gonna work, okay? Terminal 30 is where your power comes from, okay? This is gonna go to a fuse block with a, whatever, let's say 20 amp fuse here, right?
Okay.
Okay. Here is the output terminal that provides power to the fuel pump. One wire is grounded, right? That's all you need to make the motor run is a power and a ground, right? Okay. So what's happening here? This terminal, 85, is grounded, right? So this is a ground. So all it takes to make this relay work is 12 volts on terminal 86, right?
Okay.
Here's terminal 86, here's the transistor, and what does it say?
12 volts.
So, when the PCM says it's time to turn the fuel pump on, it turns this transistor on by means of the base, sends that 12 volts to here, the relay contacts close, sends that power from here to here and the fuel pump runs. Now, if this was backwards, it would do the same thing. If this was supplying a ground and this had power on it, typically this is gonna be connected to this, so these both have power at the same time. So then all this needs is a ground on this terminal, and it does the same thing. This is what they call a high side driver because it's supplying voltage, okay? I think we're gonna probably see the same thing, only using a low side driver, which will, I think, might be the next one we'll see.
Okay, Lana, maybe overthinking yet again.
Okay, hang on. Let me see if they're gonna give us, oh, okay, maybe not. Okay, so what's up?
So the PCM communicates with the ECU simultaneously to send that information to the pump relay because it already has a ground and voltage to it. So the PCM comes in to give it that extra boost, basically? Or does the PCM give it the okay? The
So-
PCM basically says it's okay to go now.
So this is your computer on the car,
Yeah,
right?
got that.
The powertrain control module.
Yeah,
Okay, so in order for this to turn the fuel pump on, it needs to have an input from something saying it's time to run the fuel pump.
so the
And what's gonna be that
PCM
input? What's the first thing that car's gonna do when you turn the ignition key on?
It's gonna start pumping.
The fuel pump's gonna run, right? If it doesn't, the car's not gonna start, right? So as soon as this gets an input from the ignition switch saying that you turned the key on or pushed the button, it's gonna say, okay, time to run the fuel pump, and it's gonna send power here. This already has power, this is already grounded. It's gonna run the fuel pump
gives it the okay.
based on the information from that. Does any of that not make sense?
No, it makes sense now, makes sense.
Okay,
Just that little extra
okay.
tidbit.
All right. This is the same thing, only this is what's called a low side driver, and the easiest way to tell, look at the schematic of the transistor here, inside the PCM. Now you see a ground symbol instead of 12 volts, right? So now, look at this. Your terminal 87 is now connected to this one. So these both have power, right? All this needs is a ground in order to close this relay contact and run the fuel pump. It does the same thing, it's just doing it by supplying a ground instead of power to the relay. Does that make sense? Yeah?
They're playing Simon Says, yes, I got it.
Okay. If you don't understand it, say something. Typical control module, high side driver. As you can see, this is the same thing again. Only it is supplying power to the fuel pump. This is your pulse width modulation or duty cycle. Remember, that is the amount of on time. That's what it looked like if you were looking at it on a scope. What is a low side driver?
Transistors inside the computer that include the ground path of relay coil.
Okay. The device makes a ground path energized. Okay. Short chapter. This stuff you should have known already anyway. We've kind of gone through this. What's going on? Oh, I didn't get this yet, huh? All right. Well, I guess I didn't get this. Okay, thanks. they still working? No? Okay. 10 out of 10, right? Okay.
Ready?
Yep, let's do it.
A, or 1A. Both sides.
Okay. And you know that how?
Cause we just went over it first.
Yeah, exactly. You know by this symbol right here,
Yeah.
right? And following the wiring of the relay. All right.
Number 2, which item is a computer output device? D, all of them.
Output, all of those. Everybody get D. Anybody not get D? Okay. Okay, anybody not get all of them? Okay. Engine mapping is the right answer. Process of manually adjusting variables such as speed, load, park timing. This is kind of what they do when they tune a car through a computer. That's engine mapping. All right. 5, where are we? Terrence, you're 5.
Which term describes via data transmission? A.
Quad rate, okay, A.
The throttle position sensor is an output component also.
It is not, it's an input. Okay,
Which sensor is used to measure manifold vacuum and
that sensor is correct.
Which computer component generates a steady stream of 1 bit long voltage pulses? It's not B, is it?
Nope.
It's A.
Clock generator, yeah.
It's on 869.
Yep.
Appreciate you.
Okay,
Number 9, the SAE term for the vehicle computer is A.
yes. And if you're paying attention to the board, it's gonna help you out. Nine and 10 you're gonna see later. What is the answer? All OBD2 vehicles use one type of read-only memory.
D.
The EEPROM. Electronically erasable programmable read-only memory, right? Right, okay. All right. All right.
Volt A.
Okay. We did the next two.
Double EEPROM. Did that
Did
one.
that one. Number 5.
B.
More basic computer functions are what?
Input,
Input,
processing.
processing, storage, and output. Right, right. This computer function is defined as a voltage signal from a sensor or switch.
Voltage signal. Input.
If it's coming from a sensor or a switch, it's an input, right?
Yeah.
Which computer device is an output? All
Did
of
that
those?
one, yeah. We did that one.
We did mapping, baud rate, clock generator, we did all of those, okay. All right. Another short, easy chapter, temperature sensors. What type of temperature sensors do we have in the cars? For what?
Coolant line.
Coolant temperature, engine coolant temperature, right? What else?
AC, AC, HVAC.
Okay. We have temperature sensors at the vent, some of them electronically controlled AC systems, right? Okay. So let's go more for just powertrain for engine performance. So we'll leave HVAC out of it for right now. This is just for this particular lesson. Okay, temperature sensors, engine coolant, what else?
Don't you have one for the,
Oil.
transmission or something?
Transmission fluid temperature,
Yeah.
TFT, right? We talked about that one. And which one did you say?
Oil.
Yeah, there's an oil temperature one, usually. Transmission, engine. Anything else? A what?
Battery temperature.
No, typically we'll have a temperature sensor on them, but they will have a current sensor on them that measures the current.
Is
Okay,
there one for the engine itself?
yeah, that's it, engine coolant temperature.
Oh, that's with the coolant, that's how you.
Yeah, yeah. I don't know if you can read it, probably should write bigger, right?
No.
Okay, what about this? What's that? IAT, what is that?
Is the I for ignition,
Nope.
intake?
Intake, yeah. Intake air temperature. What is the temperature of the air going into the engine? Okay?
Yep.
Those are the most popular ones. Let me look real quick, see if there's anything in the book quiz that we didn't cover. Looks like we did all of these except for number 4 on 872 is bringing the computer to the CPU. The rest of these we did except for 9. What 2 things can a computer actually perform as outputs?
I'm sorry, what was that question?
Number 9.
Number 9?
Is it B?
Yep, turn something on or off.
What page are you on, huh?
873.
Oh, you went back to the.
Yeah, I just went back to that chapter quiz just to make sure there was nothing on there that we didn't cover. Okay, so 10 we didn't do either.
Analog to digital converter.
Yep, AD converter. All right.
What do you get with that?
C.
AD converter, analog to digital converter. Remember the computer can't use analog signals? Remember that pattern that showed you? It showed you a waveform, and then it showed you a digital signal kind of overriding it. That was what the AD converter does. It takes an analog signal, converts it to digital signal so the computer can understand it. It doesn't understand this language. It has to be converted or translated. Right? All right. Purpose function testing of coolant temperature sensors. You can do that with a scan tool. You can do it with a digital multimeter checking ohms, all right, resistance. Diagnose problems resulting from malfunctioning temperature sensors, how automatic transmission fluid temperature sensor affects transmission operation. We've gone through that in transmission lessons. Purpose of temperature sensors for cylinder heads, fuel, exhaust gas, recirculation, engine oil. A lot of sensors on there that we didn't talk about, but just wanted to get an idea of what the most common ones were. All right. Computer. Control vehicle is equipped with a coolant temperature sensor That helps to adjust fuel delivery, ignition timing, and adjust target idle. So tell me why the engine coolant temperature sensor would adjust fuel delivery. Why would the computer want to know what the engine coolant temperature was in order to know how much fuel to give the engine?
Because if it's too hot, it can give more fuel to cool it down. It's like a hot pan on a stove. If the oil gets too hot, you add a little bit more and it helps cool it down.
Okay, you're not on the right track with that. It's not like cooking.
Now,
No.
so the extra fuel going in does not help cool it down?
No. Why would an engine coolant temperature sensor affect fuel delivery? It's used to adjust that as well, but my question is, why would the engine coolant temperature affect fuel delivery? Say what? Okay, so, let me ask you this.
Would it be for when, if like the engine's just starting and it sends in more fuel?
Exactly,
Oh.
that's exactly right.
What happened? What?
A cold engine requires more fuel.
Yeah.
Cold engines are not efficient. Engines aren't designed to run at startup temperature, okay? They are not efficient, they don't like to be cold, they like to be at operating temperature. When the engine's cold, it needs more fuel. So, in order for it to know how much fuel to give it, it needs to know what the temperature of the engine is. As the engine warms up, it gives it less and less and less. It also adjusts the timing and idle speed. You notice when you first start your car up cold, the idle speed's a little bit higher than it is after it warms up? Because again, the engine's not as efficient, wants more fuel, it's not really happy when it's cold. Then after it warms up a little bit, idle comes down a little bit, engine warms up and starts running better, needs less fuel. Okay, that is the reason. You need to know these things because this is all part of engine performance and you have to know why and what things do and why they happen, okay? This is the purpose. The sensor is a semiconductor material, decrease in resistance as the temperature of the sensor increases. What do we know about current or conductivity of just a regular wire? Since we went through this already. If temperature goes up, what normally happens?
The
To resistance.
goes up.
Okay, in a normal wire, right?
Mhm.
If the temperature goes up, the resistance goes up. What happens here?
Resistance as the temperature.
Okay, so this would be a regular wire, right?
Uh-huh.
This would be your your temperature sensor.
So is that the only?
So as the temperature goes up, resistance goes down.
Is that the only time that happens?
What do they call
For
these?
resistance?
Negative temperature coefficient, NTC sensors, remember? We covered this before.
Which
Okay.
chapter was that we covered that in?
What's that?
Which chapter was that?
That was at the beginning of the electronics part from last block. When we did all of the circuits and stuff like that.
Oh,
All right. So, in order to give you a more accurate or broader range of a sensor, sometimes they have a step-up resistor inside the PCM that will change the effective range of the sensor. So, how it works is when the temperature is low, usually below 120 degrees which for an engine, that's cold, right? Intercooler temperature, voltage is applied through a high value resistor inside the PCM. When it goes above 50 or 120, voltage is applied through a much lower resistance value in the PCM, which they call stepped. Where is that? There it is. Two-step intercooler temperature circuit. You don't really have to worry too much about knowing this, but this is just an example of what happens to give the sensor a broader range. And this is what it would look like on a chart. You can see where the voltage changes rapidly. You see why it does that? You see how fast this would just get to here if it didn't do this and then do it climb again? Okay, this gives the sensor a broader range of temperature. Okay. How would you test a coolant temperature sensor to see if it was bad? Or what would be, let's, first of all, how would you test a coolant temperature sensor?
Using a multimeter.
Scan tool.
Okay, those are the two ways you do it, right? You would look at the scan tool, and you would use your digital multimeter, right? So, like we talked about before, let's say you put your meter on the coolant temperature sensor leads, you unplug it, and you put the meter on the sensor leads, and you read the resistance of it. How are you gonna know if it's good or bad? You're gonna have to know two things. What is the temperature of the sensor? Is it in the engine or is it out of the engine? If it's in the engine, you're gonna have to know what the temperature of the engine is and know if the resistance is right based on that temperature. Or you could just use the scan tool and look at it and say, okay, the engine is this temperature. You could compare it to other sensors, see if it's good or bad. Most likely, if it's skewed or out of whack or if it's bad, the check engine light's gonna come on. Okay, the computer is pretty smart about recognizing bad sensors. Okay, it compares information from one to the others, and if something doesn't seem right, the check engine light will come on. Some codes on some types of vehicles, they'll even say sensor value, intercooler temperature sensor value not plausible, meaning it doesn't make sense based on the other sensors. So this one must be bad. Okay? Make sure the cooling system is properly filled, make sure the cap is good, make sure the mix is proper, which it normally is. Make sure the cooling fan works. You can test the cooling fan with the scan tool as well.
And is this correct that the maximum difference between, so you would take two readings, is that what this is saying? When you're testing it, you read the scan tool, you would take two readings, and that the difference between them should be 10 degrees, the max difference should be 10 degrees Fahrenheit?
Right. Between the intercooler temperature and the intake air temperature when the engine's cold? Yes. So if the car is set overnight, you can look at a scan tool and say, okay, this is the intake air temperature sensor and this is the coolant temperature sensor. They should be within 10 degrees of each other. Yeah. Okay, if you're using the multimeter, compare the resistance to a chart depending on, if the sensor's out of the car, let's say it's 90 degrees outside, you could look at that chart. Say at 90 degrees, this sensor should read 4,000 ohms or whatever, right? Okay. Just compare it with the actual temperature of the engine. You take the resistance of it like that, just kind of like we did that NOx sensor, right? One terminal and one on the other. Okay, 2,400 ohms, right? 2.4 K. So depending on the temperature of that sensor, you would know if it was okay, right? This is just showing you how that voltage drop works inside the PCM. Okay, 3 ways to test it: visual, multimeter, scan tool. All right, the intake air temperature sensor is also an NTC, or negative temperature coefficient thermistor, meaning it's two wires. Decreases in resistance of the sensor, increases, which is opposite of just a normal conductor or piece of wire. The intake air temperature sensor is used as an input to the PCM. That also will determine a little bit of fuel delivery, spark timing, not quite as much as the engine coolant temperature, but a little bit. Most of the time, cars do not have a separate intake air temperature sensor. It's built into the mass airflow sensor. Okay? So, most likely, if this is not reading right, you're gonna have to replace this, because they're incorporated too. Older cars used to have a separate one, and then they decided, let's just put it in the mass airflow sensor. Don't have to make a separate sensor, makes it easier, less money to manufacture. This is an older car with an intake air temperature sensor separate. Okay, it's gonna be in the air hose from the air filter to the throttle body. Newer ones, they got rid of that. Intake air temperature sensor and coolant temperature, this says it should be within 5 degrees of each other. That might be more accurate than 10. We know what a negative temperature coefficient sensor is. Transmission fluids temperature signal. We checked this, or we looked at this before we did transmission. It will change the shift points. It could change where the torque converter is locked or not, depending on the transmission fluid temperature. If the transmission fluid temperature gets too hot, it'll lock the torque converter up to reduce slippage, try to cool it down, okay? It'll change the shift points, stuff like that. Some engines have cylinder head temperature sensors in them now. This is actually pretty common. When two of them are used, they can more accurately determine the engine temperature. So a lot of engines will have cylinder head temperature sensors and one for the actual coolant temperature. I think this cylinder head actually has a spot for a cylinder head coolant temperature sensor in this one. Somewhere.
This.
Maybe not. All right. Some vehicles will have a fuel temperature sensor. Those are on your electronic returnless systems. Give PCM information regarding the temperature of the fuel and therefore the density. Okay, we'll get to EGR, but some of them will have an EGR temperature sensor, and that does, basically that monitors whether the EGR valve is working or not, or the EGR system is working or not. We'll monitor the temperature of the exhaust passage between the EGR and the intake manifold. If it increases when it's commanded on, then it's going to assume it works. If it doesn't, we'll set a code for the sensor or the system. Oil temperature, they use that for oil life monitoring mostly. Okay? And remember, if you don't drive your car much and the engine oil doesn't warm up, you need to change the oil more often. So that is one of the things your oil temperature sensor is used for. Okay. Temperature sensors, there you go. You've got the class rules, didn't you? Huh?
I didn't hear what you said, I'm sorry.
Okay, everybody ready?
Yeah.
Thank you.
When testing the ECT sensor with the connector disconnected, the technician should select what position on the digital multimeter, B, DC volts.
Okay, first of all, were you not done? Tiffany?
No, no.
Okay, so let's hang on for just 1 minute.
Drink one of Milo. Milo teas at Walmart? It ain't Dave's anywhere. Tea, sugar,
And it takes all kinds of time.
Okay. Go ahead, read that one again.
Ready?
Yeah, go ahead.
One is B, DC volts.
Well, it's not B.
Huh?
If you're gonna check the sensor with the digital multimeter, what are you looking for? Sensor's not gonna produce a voltage.
It says, oh wait, it says, to test for voltage at the ECT sensor, select DC volts on the digital multimeter. Or am I just looking at something completely different?
What page is that?
876, at the bottom. To test for voltage at the ECT sensor, select DC volts on the digital multimeter. And carefully probe the sensor wire and read the voltage. It starts at the bottom of the paragraph on the left-hand side of the page, and then back to the top at the right-hand side.
The sensor is disconnected.
Okay, so where you at?
Right here.
Okay. Here's the problem with that.
Mm.
You're reading that right, but that's not what the question's asking.
With the connector.
The key word
disconnected.
in what you just read is back probe. That means the sensor is still connected to the engine.
So I can't find where it says it's not connected.
Ohm scale. So if you were just gonna check the sensor, remember when we checked this knock sensor the other day? You're the one that checked it, remember?
Yeah.
Okay, this only has one terminal, so we had to put one lead on the ground. That has two, so you just put one on each one. We checked it resistance, right?
Mhm.
The only time we did voltage is to see if it actually worked, when the pressure was applied to this crystal. Okay? So if the sensor is unplugged or off of the car, ohms. If you're back probing it with it connected to the car, then voltage, yes, because the PCM is supplying a voltage through that resistor.
Alright, so where did you guys find it where it said it was disconnected?
Well, I mean, right there it says how to do it while it's connected. You just think of how to do it while it's not disconnected. I mean, while it's disconnected.
All of these
My thing
charts
is, you
here,
didn't even know where that was at first.
all
So
of
I'm
these
trying to
charts
figure out how you
here
guys figured that
are
out.
giving you resistance based on temperature. And here's your voltage if you were going to back probe it. This is the sensor itself. This is the temperature. Okay? Everybody got that? I can see how you got that answer, but again, it says right here, here's the word. With the system disconnected. That sentence you read said back probe it. Back probe it means it's still connected and you're back probing the wires to see how it is active in the system. Okay.
With the back probe, is DC voltage
Yeah.
If you were back probing, it would be voltage, absolutely, yes. But as you can see, the question reads disconnected. Okay.
Number 2, the IAT is being tested. After the vehicle has been allowed to cool for several hours, a scan tool is used to observe the IAT and compare it to the engine coolant temperature ECT. The two temperatures should be within how many degrees Fahrenheit of each other? A5.
Yeah, weren't you reading 10 somewhere earlier?
On page 878.
Because I think it is supposed to be 5, but does it say 10 somewhere?
You said 10 and the book said 5, I think.
No, on page 878, right underneath that note, it says the maximum difference between the two readings should be 10 degrees Fahrenheit. Because on the previous page,
see
it
it.
says testing the ECT sensor using a scan tool.
What?
And then it goes through to 878, where the maximum difference between the two readings should be 10 degrees Fahrenheit, 5 degrees Celsius.
What answer do they want?
This says Fahrenheit.
So, yeah, this is.
So it's 10.
This is 10. But if it says degrees, it could be 5.
If we were to say Celsius, it'd be 5. It says Fahrenheit, it's 10. The two temperatures should be within how many degrees Fahrenheit of each other, not Celsius.
Which is it?
I'm trying to, I'm not sure I'm understanding what they're saying here.
The maximum difference
Record
between the two
the
readings.
record the scan tool temperature of the intercoolant temperature, measure the actual temperature. Okay, that's different. That's different. That's the actual temperature and the scan tool reading. This is asking what is the maximum allowable temperature difference between your engine coolant temperature and your intake and air temperature sensor after the vehicle has been sitting for hours or overnight, and it is 5 degrees.
What page is that
Why
on?
are these questions so unspecific?
Oh, I see page 880, testing the intake air temperature
yeah.
sensor. If the intake air temperature circuit is damaged or faulty, a diagnostic thermostat, the
Right.
malfunction indicator linear. Okay, to diagnose the IAT sensor.
It tells you right there in step 1.
Yeah.
They should be within 5 degrees of each other, yeah.
step one,
Yeah,
step
so,
two, step
The other one was the difference between the actual and what the sensor reads. These are between the two sensors. One measuring the ambient air temperature basically and the engine coolant temperature. Okay.
And then also, can you go back to number 1 real quick, because kind of what Maurice was saying on page 879, on figure 74-7, it says an ECT sensor being tested using a digital meter set to DC volt.
We just went through that,
Yeah, I know.
but it's not disconnected. Look, keep reading. Carefully back probe the sensor wire. That means it's hooked up and functional with the computer.
Okay, okay.
The sensor itself, the question reads disconnected. Once you disconnect it, you're taking the voltage from the computer away from it. Then you're just checking resistance.
Okay,
Okay.
if you could seeing that again while looking for that other, just kind of confused me.
Yeah, that's okay. No worries. I'm here to clarify it, hopefully. Okay. All right, where are we at? 4?
3.
3. Oh, 3, okay. We haven't got very far, have we?
3, technician A says that other temperature sensor that operate like the ECT include transmission fluid temperature and the engine oil temperature sensors. Technician B says that all temperature sensors increase in resistance and the temperature decrease. Who's right?
A.
A.
A is right, because not all of them work that way. We know that sometimes this is a bad word, right? When they say, oh, all of them are like that. Depends on what it is, but. All right, number 4. B, the sensor that determines fuel delivery when a fuel injected engine is first started is the engine coolant temperature sensor. Correct. Terrence, it's all you.
Number 5.
Yes,
Zero
sir.
paper.
I'm sorry.
Never mind. The AAP 0113 DTC is being discussed. Condition A says that the IAT sensor could be internally electrically shorted. Condition B says that the PCM could be detective fluid right. B.
Okay, how'd you find that?
I suggest.
What?
I suggest.
I guessed also.
You're not supposed to guess. All the answers are in the book.
Are we supposed to know these codes?
There will be some codes, but they will tell you what they are. If you use the chart in the book on 882, you can answer this question.
Oh, I see.
First of all, what is a DTC? What does that stand for? Your question, Terrence, what is it? What-
ECT.
Oh,
What does that stand for?
trouble code.
I'm not sure.
What's that?
Not too sure.
Diagnostic trouble code. This is as basic as it gets with cars. You guys should have known this a long time ago. Diagnostic trouble code. What is IAT? Intake air temperature sensor, right? What is PCM? Powertrain control module, right?
Yeah.
If you don't know what these acronyms mean, it's going to be hard to answer the question. What did you say the answer was? B? Okay, look at the chart and tell me if that's correct or not, since you guessed at it.
That's oh, 3.
What chart?
What chart?
Yeah.
882, the bottom of the page.
A is also right?
No,
No, it says
it's open,
open.
not shorted.
Yeah.
So read the chart, read the question, tell me what the answer is. And if you want to keep your answer, that's fine too. Just tell me what you think it is.
I'm gonna keep my answer.
You're going to keep your answer?
Yeah.
Okay. You would have been a lot more sure of it if you would have looked at that, right? But you are right. But a guess is not really what we're here for. Okay, number 6.
Technician A says that the ECT and the IAT sensors can be tested visually as well as by using a digital multimeter or scan tool. Technician B says the ECT sensor is a high authority sensor in a startup and is used to open loop control as well as idle speed. Who's correct, Bob?
Both of them?
Yeah.
Okay. Might see that question later. In fact, you will.
A P0117 ECC is being discussed. Tech A says that the ECT sensor could be internally shorted to ground. Tech B says that the signal wire could be open. Who is right? A.
Okay, did you look at the chart?
Yes, sir.
Okay. Then you are correct.
To a technician, they're discussing a step DCT circuit. Technician A says that the sensor used for a step circuit is different from the one used in a non-step circuit. Technician B says that a step ECT circuit uses different internal resistance inside the PCM. Who is right? Both.
Okay. Tech A says the sensor used in a step circuit is different than the one used in a non-step circuit. Tech B says that the circuit uses different internal resistance inside the PCM. The sensor is not different. They're all the same. As far as that, the stepping process is done inside the PCM. All right. Number 9.
When testing an ECT sensor on a vehicle, a digital multimeter can be used and the signal wires back probe. What settings should the technician use to test the sensor, DC?
There you go. There's your wording that you saw the first time, back probe. Now we're at volts. Okay? Okay, question 10, there's a chart you can use for that one too. 876, I believe the chart is on.
Oh, it's not the one on 881?
This is resistance based on temperature. So, what does the meter read? 3,000 ohms? Is that what it says? Okay. Tell me approximately what temperature that engine should be.
What page are you looking at? Oh,
It's a
880.
G.
876.
That's June.
Would it be B?
Oh,
Would it be B? Approximately 70 degrees, right? Okay, is that what you're getting from that chart?
Yeah, so yeah, C68. So
Yeah, I mean, close enough. because it's not giving you that exact resistance in there, but 70 degrees. Yes,
All right, so that confused me because the charts had different vehicles on them.
yes.
I went to 880, because I originally went to 881, but that's old. So then on 880, it has the intake air temperature versus the resistance and voltage drop. Oh crap, that is still the wrong thing. So yeah, so shouldn't we look at that chart on 880?
No, 876 is the chart you want. So all you gotta do is look up, ohms, let's see. Well, there's not one that says 3,000, there's one that says 3,500, that's 68 degrees. So your 3,000 is gonna be up 70, close enough. Right?
But that says General Motors and the other ones are for Ford and Chrysler.
Yeah, I know. It says typical, I think that's what they're looking at.
So whenever it says typical, go by GM?
Yeah, I would, yeah.
Okay,
Yeah.
okay.
Okay. Let's see, we'll do quiz B on this and we'll take today on break, but that's okay. We'll take a break right after this. B, let's see. Okay, so I showed you what you needed to remember out of those questions, didn't I? If anybody was keeping our eyes up here, which I told you you should.
What was the answer for 10?
10,
Yeah.
B,
Okay, this is-
remember back probe, volts, disconnected, ohms.
No, 10, 10.
70.
It would still be.
Oh, was I reading you the wrong question?
Yeah.
Oh, okay.
We did that one.
Did we do them? The other one was 13, this is 18. It's technician B.
Okay, it was technician B. Okay, 70 degrees. This question, you'll see later. What was it? Both of them, right? Okay. This one, you're going to see later. What is it?
B.
Okay. All the following are approved methods or tools when diagnosing an engine coolant temperature sensor except for one of them.
D.
Except for this. You don't remember seeing that anywhere, right? Observing the resistance to the specified temperature, digital multimeter scan tool, yes. No. All right. What type of circuit is shown in this schematic?
B.
B?
Because
Okay.
it's the high voltage when it's cold and low when it's hot.
Mhm. Good. User 117. We did this one, didn't we? Or no?
Technician A.
Use your chart and see what you think. A?
Yeah.
Okay, yeah. A. 5, yeah. Temperature sensor decrease. What do you think about 10? I'm sorry, 9.
Both.
It's only one of them. How about that?
Um,
Yeah, that's true.
A is true.
Yeah, cause when the, oh no, it's opposite.
It's called the negative temperature coefficient.
Yeah, it's opposite.
This is wrong, right?
Yeah, that's opposite.
Okay, so, yes, they use a step circuit inside PCM
Yeah.
to broaden the range of the sensor. Okay, and we did this one, right? This guy says all of them, no, it's not all of them, so we just got A here.